everyone, we're going to graph and find points of intersections, and this is with a rational function in a circle. Before we get started, let's just look at these. The first one's the rational, has a vertical stretch of 4, and also it's a horizontal shift to the right by 3. And you should know what the parent function is for this. This would be y equals, I'll do that on the graph, but it should be y equals 1 over x. So if you know what that looks like, this is fairly easy to graph. In this one, the circle, we're going to write it so we can see the center by completing the square. So we're going to complete the square. Half of 6 is 3 and squared, and you get 9. So we made a perfect square trinomial. And move the 1 over to the right side. We also have to add the 9 to both sides. And when you condense this, we're going to get x minus 3 squared plus y squared equals 8. So just for graphing purposes, that would mean my center is 3, 0, and my radius is the square root of 8. So the hard part is going to be the algebra and using substitution. So what we're going to do on this one, the last one we did, we just substituted the y into this y here, but that's not going to work very well because we'll have to use the quadratic formula. So what I'm going to do on this one is go ahead and solve for x, and when you do that, you're going to get x equals, if you cross multiply, you get xy minus 3y equals 4. And to solve for x, you're going to go xy equals 3y plus 4. And you divide both sides by y, you get x equals 3 plus 4 over y. All right? So I'm going to rewrite this as x equals 4y plus 3. You don't have to, but I just did. Now I'm going to substitute this x into both of my x's here. So we're going to get 4 over y plus 3 squared minus 6 times 4 over y plus 3 plus y squared plus 1 equals 0. Now expanding this, we're going to get 16 y squared. This is your a plus b squared. You know that should equal a squared plus 2ab plus b squared. So that's all I'm doing here. So it's 16 over y squared plus, you multiply 4 times 3 is 12, then times that by 2, and that's going to be 24 over y, and then square your 3 and you get 9. And then on this part, you're just going to distribute the 6, get negative 24 over y minus 18 plus y squared plus 1 equals 0. Now, simplifying this, these two cancel. We're going to collect all our like terms, and we get 16 over y squared plus y squared minus 8 equals 0. The next thing I'm going to do is multiply everything by y squared to clear the fractions here, and you're going to distribute here. And when you do that, you're going to get y to the 4th. Well, let's do it the other way first. So what you'll get is 16 plus y to the 4th minus 8y squared equals 0. And I'm going to rearrange this, put it in the correct form. So this is y to the fourth minus 8y squared plus 16 equals 0. Now we have a perfect square trinomial, and this is going to be, when you factor this, you get y squared minus 4 times y squared minus 4, which is the same as y squared minus 4 squared. So we're going to set this to 0 to solve for my y. And so you get y squared minus 4 equals 0. Y squared equals 4. And when you square root both sides, you do plus and minus, you get y equals plus or minus 2. Now that I have this, I'm going to rewrite my x. My x was 4 over y plus 3. So I'm going to plug in my, I need my points. So I have 2 and negative 2, but I need my x. So just plug into this equation. So you get x equals 4 over 2 plus 3. This is just 2, so 2 plus 3 is 5. So there's a point. And then plug in negative 2, so you get x equals 4 over negative 2 plus 3. That's just negative 2 plus 3. This is negative 2. Negative 2 plus 3 is just 1. So we have, these are our points of intersection. Now we're going to graph these, and we already set this up. I'm going to go ahead and graph the circle first. So our center was 3, 0. So we go over there, 3, 0 is right there. And my r is square root of 8, which is really close to square root of 9, which is close to 3. So I go right to 3 here. 1, 2, 3. Down 1, 2, 3. And over 1, 2, 3. Close to 3, but not quite. And then just kind of draw your circle. Okay. All right. And we know this one is a horizontal shift to the right by 3. We also have a vertical asymptote at x equals 3 because you can't divide by 3. That would be 4 over 0. So we have our horizontal asymptote our vertical asymptote at x equals 3. I also know my intersecting points were 1, 2 and 5, 2. And this was negative 2, sorry. So basically, when you graph this, you go back to your 0 here, and 4 is the vertical shift. So from here, you're going to go up 4. It's a vertical stretch. You go up 4, 1, 2, 3, 4 over 1. And you go to the right from your center, 1, 2, 3, 4, up 1. And then also we have 5. This is 3, 4, 5, 2. I'm using this as an intersection point. So there it is. Intersects right in there. We also have a horizontal asymptote at x equals 0 here. Okay, and then for this side, you start at your center again and use your vertical stretch of 4, and you go over 4, 1, 2, 3, 4, down 1, and back to your center and go down 4, 1, 2, 3, 4, to the left 4. And then our intersection point is at 1, negative 2. It's right in here. All right, so that's going to be kind of like that. Down 4 over 1. So here we go. That doesn't look good, so let me do this again. There you go. It's right here. So down 4. 1, 2, 3, 4 over 1. So right through here. And there is your graph. And that's all. Thank you. Have a very nice day. Bye-bye.